Good afternoon and welcome all. Today our esteemed guest is Dr. Suhail Ahmed. Sir is Senior Scientist and in charge Archer India Grassland and Forest Research Institute. Sir, we welcome you on behalf of the dignitaries, on behalf of the organizing committee and on behalf of the students. This is really great privilege that we have today with you with us. Sir, you are audible, your presentation is visible. Please continue.
A very good afternoon to all the esteemed participants of this 21 days summer school on horticulture and allied sectors for livelihood security and environmental sustainability. Of horticulture and other land use systems. This is a unique concept. Although farmers have been practicing this form of integrated approach since time immemorial, but of late, this aspect is gaining momentum because of various, I would say, buzzwords like conservation agriculture, conservation horticulture, sustainable horticulture. So this concept is very important as we have to increase the per area productivity of all allied sectors in horticulture and also in other sectors like livestock sector. So this is a concept that revolves around wherein we use various perennial forage crops or in combination with fruit crops because we have a lot of orchard space available in fruit orchards. So that orchard space can be used for growing various perennial forage crops, and it is one of the nature positive solution wherein it leverages ecological intensification for enhanced ecosystem services. And this presents us with the complementarity between various enterprises. Say, for example, in this case, that livestock sector as well as horticulture sector, they are both known as sunrise sectors because of their immense contribution to gross domestic product of any country. Say, for example, in our country, the comparison of horticulture as well as livestock sector is 1/3 of agricultural GDP in our country and in Himalayan states. For example, if I talk about Jammu and Kashmir, Uttarakhand, and Himachal Pradesh, it contributes more than 35% to the state gross domestic products of the respective states. So in this system, we have one principle that is complementarity principle that in which both the components are equally benefited. So it optimizes the interactions between various components and various abiotic and biotic environments that increases the overall productivity and efficiency of the land use system, and also its sustainability. It sustains the production or the productivity levels for our future generations. And the principal aim of this system, of any sustainable system, is that it enhances environmental quality and also the resource base on which agriculture or horticulture depends. It provides basic human and fiber needs. It's economically viable and enhances the quality of life for farmers and society as a whole. And a sustainable agricultural system includes, for example, we resort to diversification of plant species. We use plants and animals that are well suited to farm soil and climate. So there is obviously tightening of nutrient cycles because in forest ecosystems, as you know, the nutrient cycles are very closed, and in agricultural systems, the nutrient cycles are very open. But in this case, for example, if we talk about fruit and forage systems where perennial forage crops are used, this is an intermediate between open and closed nutrient cycles. So there obviously is tightening of nutrient cycles. So obviously uh, one livestock can be integrated in this particular system because we have forage biomass available for feeding of livestock. Say, for example, the UT government of J&K has started the concept of horty sheep, where they are providing maybe few units of sheep to their orchard districts. So they also provide some perennial forage, for example, red clover distribution or any other crop to be intercropped in the orchard system. And there are other benefits, net positive effects on the environment. If we talk about the ecological and socio-economic benefits, wherein we integrate livestock with crops and trees, it helps, for example, in mitigating climate change. You know that climate change is a bigger threat to the productivity or to the sustainability of any agricultural system. If we see the present concentration of carbon dioxide in the atmosphere, it is roughly around, I think, more than 420 ppm. And if we compare it with the levels that were in the pre-industrial era, that is maybe before 1700, it was only 280 ppm. So there has been an increase, a double-fold increase in the concentration of carbon dioxide in the atmosphere. And so is the case with other greenhouse gases, including carbon monoxide, some other chlorofluorocarbons, and also methane. Then if we come to soil and water conservation, I already talked about that it helps in tightening the nutrient cycle, so there will be more availability of nutrients in the soil. It enhances resource use efficiency. It helps in water management because these are perennial in nature, so some sort of biomass will always be retained on the soil floor or orchard floor, which will ensure not only soil but also water conservation. Then, if we talk about food and nutritional security, it addresses various sustainable development goals, including zero hunger. We know that it reduces malnourishment, so it increases food security because you get to have several benefits from a particular land use system. For example, in this case, you we get fodder for the livestock, we get livestock products, we get milk from the livestock, we get fruits and vegetables from the horticulture sector. So obviously it addresses hunger and it reduces malnourishment. Then if we compare it with overall well-being of humans or the society as a whole, it by default is a sustainable land use system. It helps in poverty alleviation. It increases farm income because of the diversification of the produce, and it provides innumerable health benefits. Then, if we see the trade-offs and synergies between horticulture and livestock sector, when we integrate any two enterprises together, there will be competitive interactions, there can be supplementary interactions, there will be complementary interactions. So our aim as a researcher, as a line development department, or as a student of sustainable agriculture, well, I would say that there has to be maximum synergy between the two sectors, and there should be less trade-offs. For example, there are synergies, as I already pointed out in my in the first slide, that both these sectors are sunrise sectors. Both contribute to providing food, nutrition, and income security to the people. So is the case with horticulture as well as the livestock sector. And you know that if we manage a fruit orchard, it involves not only the management of the orchard trees. For example, in this photograph, you might see that apple fruit tree is there. So our aim should not only be also the soil, the floor on which these apple trees grow. And we know that orchard floor management or the soil management in orchards is very important for tree health, for yield, and for food quality. And it has been observed that the standard management practices, if we see the literature, especially the work that has been done in um, European countries or in Australia or in New Zealand, a lot of work has been done in this respect. That is, we maintain a vegetation-free tree row and a grass-covered alleyway, what we call as sod culture. So this system effectively controls weeds and creates a very favorable environment for the fruit trees. Then coming to livestock, they definitely are the drivers of socio-economic upliftment because and for livestock to have increased or enhanced productivity, we need adequate, nutritious, quality fodder to be fed to the livestock. And where from we get this fodder? Obviously, uh, the land that we have. If we see the All India data, the area under fodder crops has been stagnant from the last several decades. It's only 4% of the total geographical area. So farmers do not educate uh, proper land for the cultivation of fodder crops. So we have to look for such niche areas. For example, in this case, we have ready-made land use system wherein orchard floor is not managed or is not used quality nutritious fodder for increasing or for enhancing livestock productivity. And second point, for example, livestock wealth is more equitably distributed than that of land. If we compare, for example, the agroclimatic zones of Maharashtra, especially the Vidarbha region, where maximum farmer suicides are reported, then if we compare it with the same similar agroclimatic region of Rajasthan, you might you might if you search the net, you will come to the conclusion that no farmer suicides have been reported from Rajasthan. But the case in Vidarbha region of Maharashtra is absolutely opposite to that. It is only because of the diversification. In Rajasthan, farmers they raise livestock, so that provides them the security against frequent crop failures. Then coming to uh, for example, so many pastoral communities, this livestock provides a source of income and employment for those sections of the society that have been left behind. They are weaker in terms of economy, in terms of their reach to more, so say for example, planning and policy making of the government. So those pastoralists entirely depend upon the livestock. So it alleviates poverty and smoothens income distribution in those pastoral areas. So livestock is not only as a saving, but it is also investment for such poor households and provides security or insurance through multiple ways in different production systems. And in view of the rich interaction between crop and livestock, it's being increasingly realized that uh, bringing together livestock sector as well as any other sector, say for example, in this case, food sector or horticulture sector, it is basically a system approach. It definitely arrests the sustainability concerns, and those are key takeaways to countries' food security. And I already talked about that the limited land that we have, because land is such a factor of production which cannot be increased. So whatever we have to use that land only. So obviously we have limited option in this case. And one more shortcoming is that farmers do not earmark adequate land for fodder cultivation. So, and there has been an increase in livestock population and matching human population, as you are already aware about this. So there is pressure on those lands, those grazing lands or grasslands and pastures uh, that has increased tremendous and affecting the carrying capacity of those grazing lands and pastures. So at the same time, we have increased demand for animal products not only globally, but if we add the national scenario, there is an enhanced demand for animal products. For example, if you talk about animal protein or the meat products or the dairy products, there has been a consistent demand for those products. And the resultant um, human demand also has shifted. Their dietary preferences have also changed. If we see if we observe the food platter of ourselves or any other person, if we compare it with what our food platter looked like, say for example, 20 years back, it was not that diversified. But this time around, it is more diversified. You have to have dairy products, you have to have animal protein, you have to have vegetables. So almost all the combinations you have on your food plate. So that has enhanced the demand for livestock products. And for livestock productivity to increase, we need quality fodder. I'm again emphasizing this point. So the possibility of increased forage production by bringing additional area under cultivation, they are limited. So we have to find ways wherein we can augment forage resource availability through alternate options. Say for example, this option which is known as hortipastoral system, wherein we integrate forage crops and fruit crops together. So this is the contribution of livestock. I already talked about this. Then, all, so whatever trends I have explained here, and there is a projection of FAO that by 2050, total meat and milk consumption in developing countries is expected to increase by twofold. So these all, uh, whatever we discussed, whatever I presented, they present both opportunities as well as challenge for both livestock as well as horticulture sectors. And if you see this graph, this is from FAO statistics, and you can very well observe that four of five highest value global commodities they are from livestock. Then coming to livestock productivity. For example, in India, if I talk about the national figure, the average yield of milk and meat is very less here. We are number one in fruit production. We are number one in livestock production. Or milk yield, we are number one in the world. But if we see the productivity wise data, the productivity is very less. It is 20 to 60% lower than the world average. And if we compare it with developed nations, it may be more than that. Maybe the proportion will be more than I think 70-80%. And what are the factors that are responsible here in India for the low productivity of livestock? There are four factors. One is feed and fodder deficiency, which accounts for 50%. Then breeding and reproduction, 21%. Uh, we are still those areas wherein not much breed improvement has occurred. So we have diseases. For example, if you recall that 1 or 2 years back, lumpy skin disease in livestock was a very catastrophic for this industry. So we had to deal with that. So that is an issue. Then management factor, how we take care, how we manage our dairy sector. So that is also one of the factors that is responsible for low productivity of livestock. Then if we compare, if we compare, we are also, I think, number one in food production in the world. Less. Same as compared to livestock. For example, in apple, the productivity is 11.43 or 12 metric tons per hectare. But in Italy, for example, it is 40 metric tons. So there is a huge gap. And in almond, for example, in Jammu and Kashmir, we have 0.73 ton per hectare. And the national average is 0.51 ton only. Whereas the global average or the world average is 1.15 tons per hectare. And there are several factors responsible for the low productivity of fruits. That is, we have old senile orchards. We still rely on conventional or traditional orchards. There is preponderance of diseases and pests. New pests have emerged. For example, here we have leaf miner problem in Jammu and Kashmir. Then root stocks and new cultivars have really not been adopted by the farmers. If we talk about the general scenario, pollination mechanism or is not that robust. Farmers, our stakeholders, they still don't have idea about the proper pollinator-pollinizer ratio in the orchard. So that is one of the factors. And one factor which I want to emphasize here is the poor orchard floor management practices. See, these initially these three, four factors, the first one, they directly deal with the fruit trees. But the last one deals with the orchard soil, that is the orchard floor. So we also, farmers also don't know about what are the proper and what are the sustainable orchard floor management practices that play a very important role for enhancing or for increasing the orchard productivity. Then you might have come through this term, that is regenerative agriculture. Our respected Director General, Dr. Mangilal Jat sir, is in every meeting emphasizing the concept of regenerative agriculture, and he himself has done a lot of work on this particular aspect. There are five principles of regenerative agriculture. One is we have to keep our soil covered. The soil should not be bare. There should be minimum soil disturbance. You might have heard about the concept of tillage, zero tillage or minimum tillage. Then there has to be maximum crop diversity. Integration of livestock is very important so far as regenerative agriculture is concerned. And maintenance of living root year round. That means use of living mulch, use of perennial cover crops is very important principle of regenerative agriculture. And if we talk about the system I am talking about or I am working on, that is hortipastoral system, it satisfies all the five principles of regenerative agriculture. We are using perennial crops, so it keeps your soil covered. We have to till the soil only at the time of sowing. Then we have to keep the soil, no need to disturb the soil for 15 to 20 years. So there will be obviously minimum soil disturbance because we are using grasses, we are using legumes and other folk species in the interspaces. So obviously it will enhance the crop diversity. And since this is an integrated system, so we have to integrate livestock in this particular case. And since these grasses, these act as living mulch, these act as cover crops. So by default, maintenance of living root year round is ensured. And if we talk about one more concept, that is conservation agriculture, there are three principles of conservation agriculture. One is minimum tillage should be there, and 30% residue retention should be there. That means whatever we are harvesting, we have to retain 30% of that. And there has to be crop rotation. That means we have to use mix of crops. Say, for example, legumes, grasses, cereal forage. So this particular system, that is hortipastoral system, if we are using perennial crops, it satisfies all these three conditions so far as conservation agriculture is concerned. And one more term is that of sustainable agriculture or climate resilient agriculture, so or nature positive agriculture. So this particular system also satisfies the conditions so far as sustainable agriculture or nature positive agriculture is concerned. Then coming to this particular system, we have developed one or two systems, one in collaboration with the main architect of this summer school, that is Central Institute of Temperate Horticulture. We had a project with them wherein we used several forage grasses and legumes as cover crops in apple orchard. So that is one system. And in the first photograph, you can see the lush green growth of the grass in almond orchard. This is Phalaris aquatica grass, very robust, very high yielding grass, very much preferred by the livestock. So you know that in both Jammu and Kashmir, or if I talk about Uttarakhand also, and in Himachal Pradesh also, The area under fruit crops is a very important area where these perennial forage crops can be introduced as intercrops. So there exists a lot of scope in these orchards, and this I would say has remained untapped for further development. So this is a sustainable land use option, and this utilization of these particular land use system uh, can really boost the forage availability because we also are deficit in green fodder production as also in dry fodder production. Uh, so that gap between demand and supply of fodder will also get reduced if we adopt this particular system. And this system also helps in arresting or suppressing the weeds that come in fruit orchards. And it improves soil fertility and other ecosystem services as well. For example, if I talk about this is a case study actually, wherein we used several forage crops like white clover, red clover, tall fescue, and orchard grass in various combinations in both apple as well as almond orchard. This is the diversification of output that we got from this particular system. We got green fodder yield up to the tune of 29.47 tons per hectare, dry fodder 10.72 tons per hectare, and we also, because these are very rich in crude protein, so the crude protein yield on dry matter basis, it was 1.60 tons per hectare. Apple leaf yield we got in this particular system 2.06 tons per hectare. Apple leaf is a very good fodder, and majority of the farmers are using this for feeding the livestock. Although some farmers, maybe 30 to 40% farmers, they burn the apple leaves, but that's not a good practice actually from environmental footprint point of view. Then also we get pruned wood biomass because pruning is an annual affair in fruit trees. So we also get pruned wood that's used for maybe getting for firewood during winter or for getting coal for getting charcoal for our because you know that one fire pot is used in Kashmir. So this apple pruned wood is a very good resource for that. So we also get fruit yield. This was basically a medium high density orchard in which we conducted this study. We also got 30 uh, tons per hectare fruit yield. Then coming to improving the fertility of the soil, you can see the organic carbon, which was initially about, this was a 5-year project. Uh, we have taken the data in 2021, which is 0.92. So the organic carbon increased from 0.67, which was suboptimal, and it increased to the sufficiency range of 0.92%. Maybe after 10 years, we can this figure might change and we can observe more than 1% organic carbon. So that showcases the enhancement or the increase of soil fertility by using perennial forage crops. And then coming to weed suppression, for example, you know that in India, yield loss due to weeds is approximately 33% of total production, and on an average, 30% of the total production cost is spent on tillage operations. So that is that's an additional burden on the exchequer of the farmer. So efficient weed control is very imperative. It's very important and indispensable for profitable fruit production. For the case of a high culture, you can see a lot of weed hamper optimum food production. Again, this particular weed, the white colored weed coming up in the almond orchard, this is a very obnoxious weed. This is Anthemis scotula, uh, a very obnoxious one. It has a very bad smell. So, and it's also perennial, so it will always be there in the orchard unless and until we remove it. And this particular second photograph, you can see also, this is also an almond orchard. This was a uh, negative control in our study on almond orchards. You can see a lot of weeds have come up in this, like Lectuca seriola, uh, and Tragopogon dubious, and several other species coming up in the orchard as weeds. And these three photographs depict the proper orchard floor management, either a high density orchard or a medium density orchard. This is from a traditional orchard. You can see the very nice orchard management by the farmer. He has also resorted to tilling in the basin and then sod culture among in between the interspaces. Then coming to effect of various treatments on weed density and weed control efficiency, we could observe that up to 80% weed control efficiency we reported in Phalaris aquatica and red clover when these two forages were intercropped with almond, and when uh, red clover and Dactylus glomerata grass, that is orchard grass, was intercropped with apple orchards. So weed density number was also less in these two particular combinations. Then, if we talk about what are the various ecosystem services and what sustainability development goals they address, you know that by the Millennium Ecosystem Assessment, we have four ecosystem services that any land use system can offer us. We have provisioning services. These provisioning services are referred to as visible services or direct benefits that are accrued from a particular system. Then we have services or intangible benefits that providing services from horticultural systems, we get diversified output in the form of fruits, in the form of fodder, livestock products. We get fuel wood also, and we get waste biomass for making biofuels. That will again be a provisioning service from a particular system. See, for example, in our study, we got fruit yield up to 15 to 20 tons per hectare, and forage on dry matter basis, 10.9 tons dry matter per hectare. So these two addresses no poverty of one, that is goal number one of SDGs, and goal number two of Sustainable Development Goal, that is zero hunger. And coming to regulating services, we have pest and disease and climate regulation. As I already discussed it, that these help in mitigating the carbon dioxide in the atmosphere. They also help in providing suitable bee pasturage or forage to the bee populations. Because if we use uh, flowering legumes, especially those with bright colored flowers, for example, red clover having red colored flower, then sainfoin having pinkish inflorescence, they attract pollinators, they attract these bees. So they are very important for pollination ecosystem. They also enhance water quality because of their effectiveness in controlling the erosion. Because if runoff will be less, obviously soil erosion will be less. So we'll be having good water quality in the reservoirs. So these perennial sod culture, it reduces soil and water erosion. It ensures good health and well-being. That is Sustainable Development Goal number 3, and Sustainable Development Goal number 6, that is clean water and sanitation. There will be less siltation in our water bodies, as is a problem. It's a very big problem in our cities, in our even in villages, that a lot of siltation is there. And These grasses and legumes, they also arrest the enhanced nitrogen that is applied in the form of urea in the orchards, because they are very rigorous users of nitrogen. And if excess nitrogen is applied to the soil, we know that it is converted into nitrate, and that this nitrate being highly water soluble, it goes into the water bodies, or it goes into the groundwater. So if it is beyond the permissible limits, beyond the critical limits, the water may be not may not be suitable for human consumption, for drinking water purpose. Then this is regulating services. Then if we talk about nutrient cycling, in the initial slides I briefly discussed this, that they help in tightening of nutrient cycles, they enhance soil fertility, they ensure carbon capture and storage. And if we are using legumes, for example, they also help in biological nitrogen fixation. And also one that is suppressing the weeds, suppressing the weed invasion in the orchards. So, for example, in our study, the organic carbon enhanced by 37% after a 6 year uh, project study. So these are the supporting services that are offered by this particular system. And coming to cultural services, for example, if you see an orchard which is having bare soil, that will not give a very good aesthetic look, and that effect is the trafficability. You cannot move into the orchard if there is a if a rainfall has occurred maybe a day before. So it also maybe now the people are talking about agritourism or hockey tourism. So if these particular systems, if you are using maximizing crop diversity, using very brightly colored legumes, so that will increase the aesthetic value, that will increase the recreational value of a particular. So these systems, they provide spiritual and religious values also. You might, while entering into a very good orchard, which is very clean, very neat, you will feel very elated. So, and if you are integrating several systems together, they are a very good source of knowledge, education, and inspiration. And also, these act as a social prestige. If a man is having a very good or big orchard, or he's also having several cows or buffaloes or livestock in the form of sheep, it is considered as a very good social prestige. So these are the cultural services, and now the world is looking about quantifying these invisible or intangible benefits. Provisioning services, for example, they are very easy to quantify. You can directly see that this much of fruit or forage is this particular system is giving. But quantifying regulating services, supporting and cultural services, although there has a lot of work been done in this aspect also in European and developed countries, they are quantifying the ecosystem services in the form of regulating, supporting, and cultural services. And when we quantify that through these services, they are then converted into monetary terms. Then comes the point of incentivization. For example, you might have heard about carbon capture or carbon trading market. So that is what? That is exactly, we are quantifying the mitigation potential of a particular land use system, and we are converting it into monetary terms. And if a farmer or any stakeholder is, say for example, uh, mitigating greenhouse gases from the atmosphere, say for example 1 ton of carbon dioxide they are mitigating, so they will get for that whatever price is being fixed for uh, per ton of carbon dioxide. Say for example maybe in $50 or $100, whatever the price is fixed. So we call that as payment for ecosystem services. So it is not only maybe in the times to come, maybe after 5 or 6 years, the government will come up with quantifying the invisible or intangible benefits from a particular land use system. So that will again play a very bigger role from these land use systems. And we not only have to increase the positive ecosystem services, there may be disservices, what we call as ecosystem disservices from a particular land use system. For example, if a system is causing environmental pollution. So that's a disservice which a particular land use system is offering. So maybe tomorrow, if these are quantified, the farmer may get a lesser price if those disservices are taken into account. Then this was the success story of utilizing interspaces from fruit orchards in Gaunderbal area. There is a cluster of villages in Sumit Valivar area, Lar area, while in one of our beneficiary farmers, Shri Zaitun Begum, she interacted with Honorable Prime Minister. The link of the YouTube is given, Facebook link is also given. You might I will share the presentation also with the uh, organizers, also the write up with the organizers. So the link, we can very well see the impact of a simple technology utilizing the interspaces in food orchards. So these are various systems that have been developed by our institute. For example, this is a system, amla-based horticulture system. Uh, because amla is a subtropical food, that's why I thought that I should also include some studies from subtropical or tropical areas. This is a GABA-based system. We get dry matter production 7.3 tons per hectare. We also get fruit production 8.83 tons per hectare. And soil carbon sequestration, we get up to the tune of 37.23 megagram per hectare. Similar values are also given for the GABA-based horticulture system. In this system, we have used subtropical grasses that are found in subtropical areas. And this is also a success story from our regional station that is situated in Dharwad, Karnataka, using inter-row spaces in mango orchards. By using, say, for example, guinea grass or grazing guinea, these are the two species that we used in this. So this was in collaboration with KVK. The benefits were that increased green uh, fodder production, which reduced the green fodder shortage from 56% to 17%, and dry fodder shortage was reduced from 48 to 15%. So this is a very robust system, and various perennial fodder crops like perennial fodder sorghum, Bajra Napier hybrid, and Guinea grass. That's the varieties BG1 and BG2 were used in these studies. But there are, you see, when there are opportunities, there are constraints, there are concerns, there are challenges as well. And in so far as hortipastoral systems are concerned, there is definitely lack of awareness about the short and long-term benefits these systems offer. There is lack of quality planting material so far as seeds or rooted slips or seedlings of grasses are concerned. They are generally not available with the various departments. Then hortipastures, they definitely can be very highly productive, but they are a bit complex to design so and manage because there is a dynamics of a three-way system because we are using fruit trees, forage crops, and animal interface. So these are three-phased interface. Obviously, it's a bit complex to design and manage. Then not much research has been done, not much extension and capacity building has been done. There is lack of that also. And although we have national agroforestry policy promulgated by the government of India in 2014, but we don't have a dedicated agroforestry mission which will uh, bring the much needed coordination and convergence and synergy among various stakeholders that are scattered in various existing missions, programs, schemes, and agencies pertaining to agriculture, environment, forestry, and rural development sectors of the government. So the future thrust should be we should have to design suitable horticulture systems for various agroclimatic zones for different land use types. Then we have to identify the suitable crops, suitable perennial pasture species, both grasses as well as legumes. They have to be identified, and then we have to develop guidelines for managing animal, forage, and fruit tree crops. Obviously, that will require greater knowledge regarding the three-way interactions that are occurring in this particular system. For example, I will give you a simple example how to develop guidelines. For example, we are spraying lot of pesticides in apple. And side by side, if we cultivate or if we grow grass in between the interspaces, so how, at what time should we cut the grass where it is suitable or safe to be fed to the livestock? So we have to develop those guidelines. We are working on this. Maybe in a couple of, in just 1 year time, we will come up with the proper guidelines that after spraying a particular pesticide, be it insecticide or fungicide, after how many days it is safe to go for cutting of a particular pasture species or a grass species. Thank you for your kind attention. It was my pleasure to interact, to talk to you, and to present my work before you. I'm very happy. I'm very uh, uh, thankful to the organizers for inviting me
Thank
to
you.
present my
Thank you.
findings, to present my talk. I'm glad to answer any questions if there are any.
Thank you, Sohail Saab, for giving us a very insightful lecture on this forage crops and its interaction in our horticultural system. Actually, sir, we are running low on our internet today because of power cut, and we are not able to connect freely. Any participants who wants to interact with Dr. Sohail Saab?